in dealing with parallelograms. Okay, so this is the specific type of quadrilaterals, and there are some properties that exist in parallelograms, and the way I want to describe these is I want to make sure that you can distinguish between the definitions of something, necessary conditions, and sufficient conditions. And so all of these are kind of, they differ a little bit. And so when we talk about the definition of a parallelogram is defined as a quadrilateral with both pair of opposite sides parallel. And so a parallelogram is defined simply by this figure. Okay, now there's other properties that are associated with parallelograms that you guys are probably aware of. But this, by the definition, is what you get from a parallelogram. And now, if we extend this and we talk about what are the necessary conditions for a quadrilateral to be a parallelogram. And so, basically, what are the properties that exist? And so, always we include whatever the definition includes. And so, all the definition's properties are included in these necessary conditions. So we know it's a quadrilateral, right? We know it has to have both pair of opposite sides parallel. So those are the necessary conditions. Well, in addition to that, we have some more specific relationships that exist for all parallelograms. Right? We know that opposite sides are congruent. And so in addition to what we know in the definition, we also know that these both pair of opposite sides are congruent to each other. Okay, we know that opposite angles are congruent. So again, in addition to what we see by its definition, we also know that these opposite angles are congruent. And then we also know that the diagonals bisect each other. And so if I draw in my diagonals here, and so these two portions of the diagonal are equal, and these two portions are equal. The diagonals bisect one another. So those are three additional properties that are true for all parallelograms, okay, beyond what's in the definition for them. Okay, so we kind of build up from the definition into just the properties that exist. And now when we get to sufficient conditions, what sufficient conditions identify is what's the minimal number or the minimal type of condition that's required in order to identify a specific figure as falling into a different category. So the sufficient conditions we're looking at for parallelograms are we're looking at what conditions are sufficient to show that a quadrilateral is a parallelogram. Okay, now it is important to note what you're starting with and what you're ending with in these sufficient conditions, because they are going to change as we get more specific in these types of figures. But for right now, the conditions that are that can specifically or sufficiently identify that a quadrilateral is a parallelogram would be the following. Right? If you have both pair of opposite sides congruent, okay, so that alone, if you have a quadrilateral in which both pair of opposite sides are congruent, you know for a fact that that has to be a parallelogram. Okay, so again, as long as you have this relationship, it's guaranteed to be a parallelogram. Okay, and each of these sufficient conditions it's unique. Okay, so this doesn't have to, they don't all have to be true. As long as you have one of them true, then the figure is a parallelogram. Okay, so you could have both pair of opposite angles congruent. That alone is sufficient to show that a quadrilateral is in fact a parallelogram. Okay, so as long as you had this relationship here, then you know you're dealing with a parallelogram. And then the final sufficient condition to show that a quadrilateral is a parallelogram would be if the diagonals bisect each other. So once again, if all you know is that these two diagonals bisect one another, then you're guaranteed that that is a parallelogram. Okay, so you are going to be asked some questions. The questions will likely be sometimes true, always true, or never true type of statements, and you identify what you're dealing with. And it'll incorporate some of the other properties I'm going to talk about here in just a moment. But these are the general properties and sufficient conditions for parallelograms. Okay, so let's talk about the more specific parallelograms, beginning with a rectangle. And once again, we'll kind of look at the definition, the necessary conditions, and sufficient conditions. All right, so with respect to a rectangle is defined as an equiangular parallelogram. And so that really is about it. It's a parallelogram that has all right angles or 4 90-degree angles. And that is its definition. So that's how you would define a rectangle. It's an equiangular parallelogram. Okay, so its necessary conditions are all the conditions or all the properties that are apparent by its definition. So equiangular, so that's part of its necessary conditions. All the angles are equal. They're all right angles. They're all 90 degrees. Okay, it's a parallelogram, so that means all of those properties involving a parallelogram hold true for a rectangle. Okay, so both pair of opposite sides are parallel, opposite sides are equal, opposite angles are equal, and the diagonals bisect each other. So all of those conditions are still true, but they're all kind of embedded within its definition. In addition to those, we have one other property that is kind of unique and necessary for a figure to be a rectangle, and that is that the diagonals, not only do they bisect each other, but the diagonals are actually congruent. They're the same length. Okay, so you know in a rectangle, okay, so again we know that the angles are all right angles, opposite sides are equal, opposite angles are equal, the diagonals bisect one another. And not only do these diagonals bisect one another, but they're the same length. So when we cut those diagonals into pieces, all 4 of these portions of the diagonal are the same length. Okay, so that's added to this necessary condition for a rectangle. All right, now as far as sufficient conditions, now as we start to talk about the more specific types of parallelograms, the sufficient conditions that we're going to be dealing with are going to be sufficient to show that a parallelogram is a rectangle. Okay, so notice here I didn't start with quadrilateral. I started instead with a parallelogram. And so when we look at the condition that I'm going to write down here, that condition or that distinction is only going to show that a parallelogram is a rectangle. It doesn't show that a quadrilateral is a rectangle, only that the parallelogram is a rectangle. And so the sufficient conditions for this would be diagonals are congruent. Okay, so what that means is if you have a parallelogram, okay, so you do need to know this relationship first. That has to be part of the given. And then you also know that the diagonals are equal to each other. If that is true, then you know for certainty that you're dealing with a rectangle. Okay, the second sufficient condition is, or actually let me come back to this one here really quickly. So let's take a look at a case where this is not true. If we were to say, is a quadrilateral with congruent diagonals a rectangle? And if you had to find sometimes, always, or never, well, it could be, right? So now it's either always or sometimes. But if you look at a figure that looks like this, here's two diagonals that are equal in length, but is that a rectangle? No. So this condition is only sufficient to show that a parallelogram is a rectangle, not to show that any quadrilateral is a rectangle. And now compare that to the second condition. The second condition is all four angles are right angles. If you have a quadrilateral, so if you have that, in which case all four angles are right angles. So we start with the right angle, extend the sides. At the end of one side, we create another right angle. At the end of that side, we create another right angle, and it intersects the opposite side at a right angle. Okay, so this by itself, all angles of a parallelogram are right angles, therefore it is a rectangle. Always true. Is that going to be true for a quadrilateral as well? Is it true that a quadrilateral with all four angles, right angles, guaranteed to be a rectangle? Yeah. So this particular statement not only is true to show, or sufficient to show a parallelogram is a rectangle, this is also sufficient to show that a quadrilateral is a rectangle as well. Okay, the top one's not. Okay, only this one is true for that. All right, the last type of figure, or questions on that. Okay, the last type of figure that I wanted to specifically go through is a rhombus. And again, if you're looking at the definition, necessary conditions, and sufficient conditions. Okay, so by definition, a rhombus is an equilateral parallelogram. So here you're looking at all four sides are equal, and it's a parallelogram. So as far as the necessary conditions go, all the properties that are embedded within the definition itself are going to be true. So again, if we look at this rhombus, we know that it's equilateral. We know that it's a parallelogram, so these sides are parallel. We know that opposite sides are equal, which we already see. We know that opposite angles are equal, a property of all parallelograms. We know that the diagonals bisect each other, a property of all parallelograms. And so all of those properties are necessary conditions, but they're embedded within the definition. of a rhombus. Okay, the additional conditions that hold true for a rhombus is the diagonals are not only bisectors of one another, but they're perpendicular to each other, which basically means they're perpendicular bisectors. Now, the only new part of this is that they are perpendicular. And so these diagonals are going to intersect at a right angle. I'm just writing perpendicular bisectors to be more specific on that. Okay, and then the additional necessary condition for all rhombi, or any rhombus, is that the opposite angles are bisected by the diagonal as well. And so what that means is that this angle and this angle are bisected, and since they're the same, since the opposite angles are equal, each of these four angles will be the same measure. Same is true for this other set. Each of these angles is bisected, and the opposite angles are equal, so each one is going to be the exact same in that respect. Okay, so those are the necessary conditions for a rhombus. All right, the last classification would be what sufficient conditions exist. Okay, and this will be sufficient to show again, starting with a parallelogram. Is a rhombus. Okay, so once again, here we're starting with parallelogram, not just a general quadrilateral. And so if you wanted to find what condition by itself can show that a parallelogram is in fact a rhombus. And the first is that the diagonals are perpendicular to each other. If you have any parallelogram, so again, you have to know it's a parallelogram first. If you identify that these diagonals are perpendicular to each other, you're guaranteed to have a rhombus. Okay, the second sufficient condition is that if the opposite angles are bisected, by the diagonals. So once again, if you start with a parallelogram and you draw in your diagonals, and these diagonals bisect the opposite angles, then that alone is enough to show you're dealing with a rhombus. Okay, now just like with the rectangle, the last one you could have is all sides are congruent. If that's the case, you're guaranteed that this would be a rhombus. And in fact, this is also true for all quadrilaterals. So this one is sufficient to show a quadrilateral is a rhombus as well. Okay. Any questions on this, the rhombus? All right. So even though I don't specifically talk too much about this, let me go through really quickly the concepts involving squares. Okay, so a square, by its definition, is both equiangular and equilateral, so it's a regular parallelogram. And so its necessary conditions are just those properties embedded within its definition. So it fits every property that we've just now discussed. All properties of parallelograms, all properties of rectangles, all properties of a rhombus. Okay, and then as far as its sufficient conditions, if you can take one condition from the rectangle and one condition from the rhombus, then you will have your square. Okay, so as far as the sufficient conditions for a parallelogram to be a square, it has to have one of the sufficient conditions from each of those.